Hello everyone, myself Dr. Ranjith Kumar Gatla, working as an Associate Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering. So in today's class, we are going to discuss about the two-port network interrelations. Okay, which means in the previous class, we have already discussed what are the two-port networks and what are the various two-port networks like Z parameters, Y parameters, H parameters, ABCD parameters. And in today's class, we are going to discuss about the relation between these parameters, which means what is the relation between Z and Y parameters and Z and H parameters and Z and ABCD parameters. Similarly, in between Y and other two-port network parameters and Z and other two-port network parameters and ABCD H. So like what is the interrelations between the various two-port network parameters that we will discuss in today's class. So before going to start discussion about on the interrelations, okay. So first let us just have a look at what are the Z parameters and Y parameters, ABCD parameters and H parameters, right? So as we know here, the Z parameters are the voltages are the functions of the currents. So the input voltage and output voltages are the functions of the input current and output current. So which means here we will write the equations of the input voltage and output voltage in terms of input current and output current. So that's what here V1 is equal to Z11 I1 plus Z12 I2, and similarly the output voltage equation V2 is equal to Z21 I1 plus Z22 I2. So here the V1, V2 are the input voltage and output voltage, and I1, I2 are the input current and output current respectively. So that's what here. So which means the Z parameters are the voltage equations, that is input and output voltage equations in terms of input and output currents. So which means here the I1, I2 are the independent variables and V1, V2 are the dependent variables. So V1, V2 are depends on the currents I1 and I2. Similarly, when coming to the Y parameters, so the Y parameters are, here the currents are the functions of voltages. So which means here we will write the equations of input voltage and input current and output current, which is I1 and I2, in terms of input voltage and the output voltage, which are V1 and V2. So then I1 is equal to Y11 V1 plus Y12 V2. Similarly, I2, which is the output current equation, is equal to Y21 V1 plus Y22 V2. So in this way, if you write these things into the matrix form, then we can write. And similarly, ABCD parameters are only referred to the input parameters, which means here the input voltage and input currents are the functions of output voltage and output current, right? So then if you write the equations, then the input voltage V1 is equal to AV2 minus BI2, and here I1 again, the input current I1 is equal to CV2 minus DI2. So here, of course, the minus sign for the I2 here, it is because of the current I1 and I2 are opposite directions to each other. So that's why here, when you refer I1 is a positive direction, then definitely the I2 should be the negative direction. So that's why here there is a negative sign wherever we are using the I2 current. Then when coming to the H parameters, these are hybrid parameters. Okay, as you can see in the Z parameters and Y parameters and ABCD parameters. Okay, so there is a criteria, which means here Z parameters only the voltages. Okay, the voltage equations. One is input voltage and input output voltage, and in Y parameters also like I1 and I2, so input current and output current, and ABCD parameters only the input side parameters. One is V1 and I1. But when coming to the hybrid parameters, it is a combination. It is a mixed combination, which means from the input port we are taking the voltage V1, and the output port we are taking the current I2. So which means here the input voltage V1 is a functions of the output current and output voltage, and similarly the output current, this is the port 2 current I2, is also a function of the input current and the output voltage. Then if you write this, in terms of, so here the H parameters, the voltage, that is input voltage and output current. Okay, so the input voltage and output currents are the functions of the input current and the output voltage. So it is a mix. I mean, some one parameter we are considered from the input side, which is voltage V1, and another parameters we are considered from the output side, which is the current I2. So that's why these are called as a hybrid parameter. So it is a mixed kind of thing. So that's why here the input voltage V1 is equal to H11 I1 plus H12 V2, and the input current I2, sorry, the output current I2 is equal to H21 I1 plus H22 V2. Then of course, we know that like how to find these Z11 and Z12 and Z22 and Z11. So as we know, the Z parameters are also called as a impedance parameters and also called as a open circuit parameters. Okay, so that's why here by if you want to find Z11 and Z12 or Z11 and Z22, then we have to make it for the Z11, the second port terminals or the output terminals are the open circuit. So that's why here I2 is equal to 0. So by making I2 is equal to 0, we can find the two parameters, two Z parameters. One is Z11, another one is the Z21. Then similarly, by making the input terminals, or which are the port 1 terminals, as an open circuit, so that the I1 is equal to 0, then we can find the two parameters which are Z12 and Z22. So here Z12 is equal to V1 by I2 and Z22 is equal to V2 by I2. So as we know already what is mean by Z11, that is the input impedance, okay, our open circuit input impedance, and Z12 is the transfer impedance between the port 1 and 2, and the Z22 is the output impedance, and Z21 is the again the transfer impedance between the port 2 to 1. Similarly, here the Y parameters also that we can find, because the Y parameters are also called as a short circuit parameters. So again, by making the output terminals or the short circuit, we can find two Y parameters, and again by making the input port once the short circuit, then we can find another two parameters. Then ABCD parameters. Okay, so here again in this case also we are making one time what is that I2 is equal to 0, because here we are finding the input parameters, that is V1 and I1. Okay, so which means V1, I1 all are referred to the input side or the port 1 side. So that's why we should not disturb the port 1 side. So that's why here at one case we are making the output terminals as a open circuit, so that I2 is equal to 0. And another case we are making the output terminals as a short circuit, so which means the V2 is equal to 0. So in that way we can find the four ABCD parameters, which are A, B, C and D. Then similarly here the H parameters. Okay, so H parameters, input side we are making as a open circuit, and the output side we are making the short circuit. Okay, so in this way we can find the H parameters also. So now we are coming to the actual topic, which is the relation or the interconnection or interrelation, not interconnection, interrelation between the various two port network parameters, right? So here first let us go with the relation between the Z and Y parameters. So which means here the Y parameters we can find in terms of Z parameters, okay, or the Y parameter equation in terms of the Z parameter equations. Which means if we are able, I mean, if we know the Z parameters, then we can find the Y parameters if you know the relation between the Z and Y. So first let us write the equation. So here this equation indicates. So here this equation indicates the actually the what is that Z parameter equation. Okay, so which is V1 is equal to Z11 into I1, and V2 is equal, Z11 I1 plus Z12 into I2. Similarly here V2 is equal to Z21 I1 plus Z22 I2. So from that equation we just written in the form of matrix. And here as we already know, so this is the impedance matrix, so we can simply call it as the matrix Z. So that's what here this equation can be converted into like this. So here Z into I1 I2, right? And if you send here, because as we know, in case of Z parameters, okay, so the voltage equations V1 and V2 in terms of I1 and I2, But in case of y parameters, the current equations I1 and I2 in terms of V1 and V2. So that's why here from the z parameters, I am trying to find I1 and I2 values so that we can equate with the actual y parameters I1 and I2 equations. And by comparing these two equations, then we can able to get the relation between the z and y parameters, right? So for that reason here, I'm just sending these z parameters to this side. Then here I1, I2 is equal to, of course, if you send 1 by z, then 1 by z is equal to, in the matrix 1 by z matrix is equal to then the z inverse matrix, right? So that's what here I1, I2 is equal to z inverse into V1, V2. And as we know already, and the y parameters equation, so these are the y parameters equations. And in this y parameter equation, here as we know, and this is called as a admittance matrix. This particular matrix is the admittance matrix, or simply we can represent this matrix as a y. So here then the I1, I2 is equal to y into V1, V2, right? So if you equate these two equations, okay, because here as you can see here, again this equation is also I1, I2, which means from here is equal to y into again V1, V2. So here as you can see, here this is I1 and I2 in these two cases, and here also it is V1 and V2. So if you equate these two equations, then in the place of y here z inverse is there. So that's why by equating these two equations, then you can get the relation y is equal to z inverse. So this is the matrix y and this is the z inverse matrix. Now if you are able to write the z inverse matrix, then you can just equate these two so that you can find the relation between the y and z parameters. So here then how to find the z? As we know already, the z inverse is equal to the adjoint of z matrix by the delta z. And you know already delta z is nothing but the determination of this matrix. Okay, so the determination of the matrix here it is the equation, like this z11 into z22 minus here z21 into z12. Okay, so that is what this equation represents. Okay, so this equation represents the delta z value, right? So then adjoint of the z is just as we know, we interchange these what is that, the diagonal elements. Okay, so like in this matrix, so we have just interchanged this z11 and z22, and we should give the minus sign. So you know already in the matrix how to find the adjacent matrix. Then if you find the delta z value and adjacent matrix in this particular equation, then you will get the value as a here like this. Okay, so which means then here this is the z inverse matrix, and you know already that is y is equal to the y matrix, which is equal to z inverse matrix. Okay, so if you equate these two, because here this is represents the matrix y, okay, and this is represents this is represents the matrix z inverse. Then if you just compare the each element, then you can find the each y parameters in terms of the z parameter, so which is y11 which is equal to z22 by delta z, and similarly here y21 which is equal to minus z21 by delta z, and similarly here y12 which is equal to minus z12 by delta z, and similarly y22 is equal to z11 by delta z. So now this is the relation between the y and z parameters. So if you know the z parameter values, then you can able to find the y parameters by using this relation. So this is how this is the relation between, and this is the way to develop the relation between the various parameters, right? So now the relation between z and h parameters, right? So which means how we can find the h parameters in terms of the z parameters, right? So for that again here we need to write the z parameter equations and as well as the h parameter equations. Okay, so first of all let me write the z parameter equations. As we know, the Z parameter equations are the input voltage and output voltage equation. And but when coming to the H parameters, it is the input voltage and output current. Okay, so that's why here the relation between the Z parameters and H parameters. So which means here we need to convert. Okay, so these equations are from these equations. Okay, so we should find V1 and I2. Okay, already V1 equation is there. Okay, but we need to find the I2 equations, so that the same way if you compare these two equations, then we can able to find, or we can able to make the uh, relation between the H parameters and the Z parameters, right? So here from the second equation, so let us consider here, this is equation number 1, this is equation number 1, and this is equation number 2, right? So in this, from the second equation, so find I2 value. So that if you want to find I2 value, so first you have to send this one to the left hand side. So which means here Z I2 into Z22 is equal to V2 minus Z11 into I1. So then again send this Z22 to the left hand side. Then finally I2 is equal to here minus Z21 by Z22 into I1 plus 1 by Z22 into V2, right? So let us consider this is equation number 3, right? Then substitute in the first equation, which means here substitute this, 3 in the first equation wherever you find I2 value. So here you are having, this is the I2 value. So then I2 value, before that already Z11 into I1 is there. So then this equation will become V1 is equal to Z11 Z22 minus Z11 Z21 by Z22 into I1, because already one I1 equation is there and here also I1 equation is there. So just by combinedly we can make it this equation, plus again here already Z12 is there, so Z12 by here Z22, so Z22 into V2, right? Then here V1 equation is there and I2 equation is there, same like in H parameter equation. So as we know, H parameter equation, V1 is equal to H11 I1 plus H12 into V2, and similarly I2 equation, I2 is equal to H21 I1 plus H22 V2. So these are the H parameters, right? These are the H parameter equations, right? So same like in the previous case also, here we from these two equations we just convert the equations into V1 and I2. So now this is the V1 and I2. So just write these V1 and I2 into the matrix form. Then here V1 and I2. So V1, what are the coefficients of I1 and what are the coefficients of V1, that you can just find. Okay. So as we know here, especially in the V1 equation, this Z11 Z22 minus Z11 Z21 is nothing but the determination of the Z. So that's why here instead of that simply I have written delta Z. So this is from this matrix, as you know, this is Z11, Z12 and Z21 and Z22. Okay, if you can find so here this like Z11, Z22 minus Z21 into Z12. So that is what this equation and this equation. So instead of this, we can write it as a delta Z. So that's why here the delta Z by Z22, the delta Z by Z22. Then similarly here in the place of V2, Z12 by Z12 by Z22. So here also Z12 by Z22. That's what we have replaced. Then similarly, when coming to the I2, the coefficient of I1 is here minus Z21 by Z22 minus then the same coefficient here I have written. And similarly, the coefficient of V2 is 1 by Z22. So here is also 1 by Z22. Right. Now, this is the H parameters. Just I have written this equation in terms of the matrix form. Then you will get like this equation. Then if you can compare these two equations, if you can compare these two matrix. Okay, so let us find here matrix. And this is M2. So if you can compare this M1 and M2, okay. So in place of H11, what is there here? this one. Okay, and in place of H22, so this. Similarly, here in place of H21, this. Okay, and in place of H22, this. Right? So the same way here H11, H12 and H21, H22 is equal to here delta Z by, okay, the delta Z by Z22, and here H12 place you are having Z12 by Z22, and in the place of H21 you are having minus Z21 by Z22, and in the place of H22 you are having 1 by Z22. So as you can see here, in all these cases the denominator is common, which is Z22. Okay, so in that way also you can just try to remember the relation between these Z parameters and the H parameters, right? So from this, I mean from this matrix, then we can write the exact relation, that is H11 is equal to, so delta Z by Z22, and similarly here H21 is equal to minus Z21 by Z22, and the same way here the other two parameters H12 is equal to Z12 by Z22, and then H22 is equal to 1 by Z22. So this is the relation between the H parameters and Z parameters. So which means if you know the Z parameters, then we can able to find the H parameters and the vice versa, right? Now the similar way, okay, in a similar fashion we can find the other relations also. So now here this matrix indicates the relation between the Y parameters and the H parameters, okay, which means H parameters in terms of Y parameter. So here also then which means here H11 which is equal to 1 by Y11, and H12 is equal to minus Y12 by Y11, and the similar way here H21 is equal to Y21 by Y11, and then similarly H22 is equal to delta Y by Y11. So this is the way, I mean, the relation between the H parameters and the Z parameters. Then the same way here, the relation between the ABCD and Z and ABCD and Y parameters. Okay, so from this relation we can write A is equal to here Z11 by Z21, and similarly here B is equal to delta Z by Z21, right? And the same way here the C is equal to 1 by Z21, and D is equal to Z22 by Z21. Okay, Z22 by Z21. Then here, I mean, again the ABCD parameters in terms of Y parameters, A is equal to minus Y22 by Y21, and again here C is equal to delta minus delta Y by Y21, and similarly here B is equal to minus 1 by Y21, and again D is equal to minus Y11 by Y21. So if you observe here these two, as you can see, just we need to write, okay, I mean just interchange these what is that, the diagonal elements, okay, and also by interchanging the sign, then you can able to what is that, write the relation between the ABCD and Z parameters and ABCD and Y parameters. As you can see here, suppose if you interchange these, because as you can see here Z11, and because here Z22, so here Z22 and Z21, okay, if you can interchange this one to here this place, okay, then here instead of Z here, if you can able to write Y, then Y22 and Y11. So as you can see here, these two are similar, only, okay, the minus sign. And the same way here, you have to replace this two here, okay, then which means here Z11 which means Y11, and here Z21 means Y21. Here the plus sign is there, so that's why you have to put minus. Then same way, even these two are diagonal elements also. So here delta Z by Z21, this is positive. So then this will come here into this place. So which means here delta Y by Y21, here plus is there, that's why here minus. And the same way here also here. So if you able to remember one equation, okay, then it is easy to write the second equation by remembering this trick, right? So this is the relation between the ABCD parameters and Z, and again the ABCD and the Y parameters. Now ABCD and H parameters here, as you can see, okay. So here ABCD and H parameters, the relation here it is, of course, by using this matrix we can know. So which means here A is equal to minus delta H by H21 and C is equal to minus H22 by H21, and similarly here B is equal to minus H1 by H21 and C is equal to minus 1 by H21, right? So finally here, as you can see, the relation between the various parameters, okay, the Z parameters in terms of Y here, okay, and the Z parameters in terms of ABCD, and the Z parameters in terms of the H parameters. These are the various relations. Similarly, when coming to the the Y parameters can be represented in terms of the Z parameters, and again the Y parameters in terms of the ABCD parameters, and the Y parameters in terms of the H parameters. Then similarly, when coming to the ABCD, again the ABCD parameters also we can represent into other three parameters. So ABCD to Z parameters, and ABCD to Y parameters, and ABCD to H parameters. The same way here, the H parameters and H and Z parameters, and this is H and Y parameters, and this is H and ABCD parameters. Then by using this matrix, then it is very easy to remember all the relations between the interrelation between the various parameters. Okay, so as you can see here, this is Z parameters, and Z and Y this matrix represent, and Z and H this matrix represent, and Z and T this matrix represents. I mean T means here the ABCD parameters, and the ABCD parameters are also called as a transmission parameter. So that's why here they have represented with a T, right? Then the same way here, the Y, the Y and Z and Y and H and Y and Z and Y and H and Y and T. Similarly, H and Z and H and Y and H and T, and T and Z, T and Y, and T and H. So if you the same way here, if you can observe, okay, the relation, because here as you can see Z and Y, okay, Z parameters in terms of Y and Y parameters in terms of Z almost same, as you can see if you can able to observe. So here, so just replacing Z as a Y, that's all. The relation between Z to Y and Y to Z, which means this is Z parameters in terms of Y and this Y parameters in terms of Z. Okay, so that's why here I have just mentioned all the parameters at one place, the relation, so that you can observe the difference between the various. Okay, and the same way here, this is Z and Y. Then if you can able to see H and Y, okay, so are Z and H. So here Z and parameters in terms of H parameters, and H parameters in terms of Z parameters, right? So these, in this case also, as you can see, okay, just I'm trying to make it one arrow mark in between these two. Okay, so if you remember Z parameters in terms of H parameters, then it is easy the H parameters in terms of Z parameters, because as you can see, just replace wherever H is there as a Z. Okay, so see here 1 2 1 2, so H and Z, H and Z, and this is also same way, right? Okay, and H and transmission parameters also, as you can see, this is the relation between H and transmission. Okay, of course here it is Z21 Z21, okay, 21 means C, and here 11 means A, and yes, of course here also the same way, these two, because here this is, let us consider A, okay, and here Z21 means here this is C, okay, and delta Z is nothing but here delta T, right? And here again Z21 means C, Z22 means D. Okay, so this is how we can easily what is that remember, okay, the relation between the various parameters. So if you are able to know the Z and Y, then Y and Z is also the similar, right? Then now we are going to discuss some numerical problems. Okay, so here the first problem is determine the Y parameters for a two-port network if the Z parameters are given. So here the Z parameters are here, it means here it is Z11 and Z12 and Z21 and Z22, right? So now already we know the relation between the y and z parameters. So this matrix represents the relation between the y and z parameters, right? So now we know the value of z11, z12, z21 and z22, but here the delta z. So delta z is equal to, as we know already, delta z is equal to determination of z11 into z22 minus z21 into z12. So which is nothing but here this 10 into 9 minus 5 into 5, so which is equal to 65. Then which means here this matrix will become, here what is z22 value? Here z22 is 9, 9 by 65, and again here z12 value is 5, so minus 5 by 65, and here z21 value is 5, so minus 5 by again 65, and here z11 value is 10, so here 10 by 65. Okay, so yes, already is matrix here, it is there. So this is what we can able to find the y parameters if we know the z parameters, because we know the relation between the y and z parameters, right? So this is how we can find the y parameters from the z parameters. Then another problem, here the y parameters from the h parameters. So we know the h parameters, like here h11, h12, h21 and h22, right? Or simply we can write here like this, h11, h12 and h21 and h22. Okay, so which is nothing but here h11 is equal to 5 and h21 is equal to 3 and h12 is equal to 2 and h22 is equal to 6, right? The same way here, I mean the relation between y and h parameters. Okay, so here 1 by h11 is 5 and minus h22 is 6 by again h11 is 5. Okay, so here h21 is equal to 3 and h11 is again 5, and here delta h is there, so delta h is equal to h11 into h22 minus h12 into h21. Then if we can substitute, then you will get the delta h value as a 24. So then substitute here 24 by again h11 is 5. So then now these are, so here then y11 which is equal to 1 by 5 and y12 which is equal to minus 6 by 5 and y21 which is equal to 3 by 5 and y22 which is equal to 24 by 5. So this is way we can find the y parameters from the h parameters, right? Then now the another problem. So determine y and z parameters for the given two-port network. So first let us find either y parameters or the z parameters. So from that we can we know the relation between the y and z parameters. Then we can find the another parameters. So first let us find the z parameters. So as we know, the z parameters are nothing but the z parameters equations are the input voltage and output voltage equation. So which means now we should write the input voltage and output voltage equations from this given network, right? So to find that one, here let us apply the KCL at the node 1. Okay, so if you apply the KCL at node 1, so here this is I1, okay, minus, okay, and which means here yeah 1, and then the same way here, if you apply the KCL at node 2, then we will get this equation. Okay, so which means here we are just applying the nodal analysis actually. Okay, so then 1.5 v1 minus 0.5 v2 is equal to I1. Then similarly here, by applying KCL at node 2, then you will get minus 0.5 v1 plus v2 is equal to I2 minus 3 I1, right? Then if you simplify these equations, okay, and make it here from this equation here, here I'm just writing. So here v1 is equal, or here I'm writing So V1 is equal to, because here we need to write V1 and V2 matrix. Okay. So, and V1 in terms of I1 and V2 in terms of I2. So if you able to write these equations, then R, because here V1 and V2 equations, okay, let us write, because here everything is in V1 and V2. So that's why if you write this one into the matrix form, then you can find here, because wherever here V1 and V2 and here also V1, V2 is there, right? But here I1 is there, then I2 coefficient here it is 0. Okay, let us consider. Okay, so 0 into I2. Then if you write this into the matrix form, then you will be having 1.5. I mean the coefficients of V1 and V2 here it is V1 1.5 and minus 0.5, 1.5 and minus 0.5, again minus 0.5 and 1. So minus 0.5 and 1 into V1 V2. And again when coming to I1, here it is I1 is 1. Okay, and but here I2 there is no I2, so that's why here it is 0. And here it is again I1 is minus 3 and I2 coefficient is 1, so that's why minus 3 and 1. Right? So then if you able to write these equations into V1, V2, I mean because we need to write V1, V2, so just send this matrix to this side, then it will become inverse. Then the inverse of this matrix, here it is, of course, you know already how to find the inverse of the matrix. So directly I have written equation. So here this is the inverse of the matrix. So which means here it is Z into, I, or I1, I2. So which means here this is Z11 is equal to minus 0.4 and Z12 is equal to here again 0.4 and Z21 is equal to minus 3.2 and Z22 is equal to 1.2, right? So then y is nothing but the Z inverse. Okay, so then the Z inverse, if you we know the relation between the y and z parameters, then if you substitute in this equation, then you will get here these are the z parameters, and when coming to the y parameters here, y11 is equal to 1.5 and y12 is equal to minus 0.5. Similarly, y21 is equal to 4 and y22 is equal to minus 0.5. So these are the z parameters and these are the y parameters, right? So this is how we can find the various parameters. Okay, so by applying the relation between the interrelation between the various parameters. So in the next class we will discuss about the interconnection between the two port networks, right? Thank you.
Like, share and subscribe. Hit the bell icon for more updates.